My name is Ashwini Dashgupta. I am a director at Cheenta Academy, and we are very pleased to have Mr. Rajiv Gandhi with us from Rutgers University. He has a very wonderful program called PACT, so he will probably talk about it. It's like a summer program, as far as I understand, and he will also be talking about algorithmic thinking, which is very critical to problem solving. Professor Gandhi, over to you. Thank you for joining in.
Thank you very much, Ashwani, and folks. I'm really excited to have a chance to speak with you all. I love working with students in general, with students from diverse backgrounds. So, without any further delay, let's just jump into what I want to talk about. Algorithms is a very vast field. I've just chosen just some very sample problems just to illustrate the power of it and so on. And So let us get started with a very simple problem called the greatest common divisor. Right. As we all know, it's many times the acronym is GCD. So we say that D is, let's say, given positive integers A and B, D is a greatest common divisor of A and B if D divides A, evenly divides A, and D evenly divides B. This is a notation to just say that integer D evenly divides A and integer D evenly divides B, right? So for example, 7 evenly divides 35, but 7 does not evenly divide 36. And for all, right, there's a symbol for all, some of you may have seen, for all E such that E divides A and E divides B, E is at most E, right? So for all integers D, I'm not being very specific, but just in the interest of time, for all E such that if E evenly divides A and E evenly divides B, then E is at most E. Right, so that is, it is saying that among all the common divisors of A and D, D is the greatest common divisor. Right. Now, I want to design an algorithm to find GCD of A and D, right? Of GCD and A and D. An algorithm is nothing but a recipe to find GCD of A and B. I don't like to hear my voice too much, so can somebody unmute yourself, or why don't I call on people and you can unmute yourself and say what you think about it. Let's say Mayank Sharma.
Yes, sir.
Yeah, how would we find the greatest common divisor of A and B?
Sir, we can find the greatest common divisor of A and B by finding the HCF of A and B.
By finding what?
Highest common factor, sir.
Okay, highest common factor. Very good, excellent. So, Mayank, how would you find that highest common factor? Let's say I were to give you two numbers. What would you do?
Sir,
okay, let's see. Tayo, you are.
Yes, sir.
Yeah, how would you do? How would you find the? Mayank Sharma just told me that he wants to find the highest common factor. How do I do that? How do I tell a computer to do that?
So first we get two numbers, and then we find all the factors of the numbers. We might of the number, and we might want to put that into an array and get the last element of that.
Amazing, amazing, very good, right? So what Tayo is saying is that, and Mayank Sharma said, is the following. They said that, look, why don't you have a for loop? In case you don't know what a for loop is, don't worry about it. It just says you go through, it just says exactly what Mayank and Tayo are trying to say. It says for k going from 1 to the smaller of a and b, it is just saying go through all integers from 1 through minimum of a and b, and ask the question, if k evenly divides a and k evenly divides b, right? They are saying, look, if k is a common divisor of a and b, then they are saying that your answer is possibly k. Answer is possibly k. And at the end of the for loop, once you are done, all you want to tell is return answer. That is that is whatever is the last number. Remember what Tayo said, you take the last element. We don't need an array, but whatever the last number is, that will be the answer. Very good, very good. Anushka Agrawal, can you tell me how many iterations of the for loop do you think this will take?
Sir, it'll take as many iterations as there are from 1 to the minimum of A or B.
Very good, right? So what Anushka is telling us is that, assuming A is greater than or equal to B, the above algorithm will take let's say B iterations, right? And how can we even expect anything to be done better than B iterations, right? Let me just, right. So do we all see, let me ask Adityananda, do we see why this is the best algorithm possible?
Yeah, because if you repeat till A.
I don't need justification, but are you convinced that the algorithm by Tayo and Mayank and Anushka Sharma is the best algorithm possible? Are you convinced?
Not really. Maybe there is something better.
Oh, okay. Okay, so if there is something better, then why didn't your teacher teach you that? This is elementary school stuff, right?
Yeah.
Okay. Divyam Das, are you convinced that this is the best algorithm possible? Yes or no?
I think so, yes, sir, but there can also be others.
Okay, all right. Okay, so in interest of time, I won't. I will just say that I will state the following claim of following theorem by Euclid. This is centuries ago. What Euclid said is that if let B be let C be equal to A mod B, right? That is the remainder when A is divided by B. Remainder when A is divided by B. Then GCD of A comma B is equal to GCD of B comma C. Right? I won't go into the proof for this. We don't have that much time. But this is what Euclid did a couple of centuries ago. Right? Now, how does that help us? Right? So what actually we can do the following algorithm due to Euclid. He says that, look, if you want to find the GCD of A comma B, just find GCD of B comma C until the remainder is equal to 0. So I won't write the precise algorithm in interest of time because I want to cover other things. But all he says is if you want to find GCD of A comma B, just do equal to GCD of B comma C. Continue doing this. Until the remainder is 0. Right, so let's just take one example and just see how it will be, right? So Euclid, let's say that Euclid wants to calculate GCD of let's say 689 and 234, right? My arithmetic is not as good as yours, so you guys will have to help me. This will be equal to, so what will be, so this is, let's say, A, and this is, let's say, B, right? This is GCD of AB. Now, this will be equal to GCD of B comma C. So B is 234, and when you divide 689 by 234, the remainder will be 221, I think. Yeah, 221. Correct me if I made some mistake.
Yes,
sorry, is this good?
Yes, sir. That's good.
Yes, sir.
Okay, good. Right, and this will be equal to GCD of 221, and the quotient will be 1, so the remainder is 13, and this will be equal to GCD of 13 comma 0. Life is good, we are done, right? So the GCD of 221, GCD of 689 and 34 is 13. Yeah. Now, how many iterations did this take, right? Just a few iterations, 4 iterations or something, right? If we would have gone by the algorithm that we discussed by Mayank, Tayo, and Anushka, then the number of iterations would have been 234, right? Right? You could have done some minor optimization, still it would have been large, right? So by this example, what I want to say is algorithms has not come into limelight because of computers. Algorithms was always there. Even centuries ago, people wanted to find efficient ways to do things, and algorithms was people always wanted efficient algorithms then. People want efficient algorithms now. When computers came, people wanted efficient algorithms. Now, in the age of big data, machine learning, people still need efficient algorithms. Yeah. Okay. All right. We are good. Let's move on to the next problem. I wanted to just introduce 3 problems just as a sample, just to give you an exposure. Next is the following problem. Interval scheduling. So imagine that I have started a new business. I have one room, let's say the room in which I'm sitting, and I want to make some money, so I can rent out the room to people during certain intervals that they may be interested in having a meeting. So on the previous day, let's say that I get all this request from people who want to request a room, right? So we have n intervals. Each interval I has a start time Si and a finish time Fi, right? And so imagine the input to be this, right? So this, somebody wants a meeting from here, somebody wants a meeting 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 here, and so on. Yeah. And I'm still a naive businessman. I just charge, let's say, $1 for every meeting, right? For no matter how long the meeting is, I charge $1, right? So everybody has to pay me $1 if they want to use the room for however long. I obviously cannot schedule, we cannot schedule, so cannot, okay, so objective is to find a largest set of non-overlapping intervals, right? I don't want to schedule two people two different requests at the same time, right? I want to give the people want the room all to themselves, right? So I want to find the largest set of non-overlapping intervals. So one possible solution, I'm not saying this could be the largest because I will have to eyeball it and just see, but I can just see that one possible solution is this and this, right? We can schedule 2 meetings and I can make $2. Yeah. I hope the question is clear, right? If not, please unmute yourself and ask me if you have questions. Vivan Rustagi, do you have a question?
No, sir. I just want to say that it was for non-overlapping activities.
Yes, so I did say that.
Yeah, I forgot to lower my hand.
Okay, that's all right. All good, all good. Baba Das, do you have a question?
Sir, so you want to make the most money possible, right?
Yes, yes. So that's why I said the largest set of non-overlapping intervals, and each interval gives me $1. Just keep that in mind, right? So for each interval that I schedule, I get $1.
Okay.
Yeah. Vian People, do you have a question?
I did not understand how to find out the GCD.
Well, we use Euclid's lemma here, that GCD of A comma B is equal to GCD of B comma C. So this is A, this is B. You divide, you take, so and okay. So this based on Euclid's lemma, this is B, so this comes here, and the remainder of A divided by B is 221, and you repeat the process. Yeah.
How did you get 21?
I'm sorry?
How did you get 221?
Because the remainder when you divide 689 by 234 is 221. Yeah. Okay. Yeah, Pranav, go ahead. Do you have a question?
Sir, I think I can have a solution to the interval scheduling problem, sir.
Okay, that's all right. Let me just have people think about it for a minute, and then we can talk. Okay. All right. Good. So, Pranav, because the answer is so simple, I don't want to waste your time giving me the solution. We can do the following, right? We can just say, give the room to the interval with earliest start time, delete or remove all overlapping intervals, and repeat the above 2 steps. Right? And this should give you the optimal solution. Pranav, is this clear?
Yes, sir.
Okay. So is this what you wanted to say, Pranav?
Well, I was taking find the interval with the shortest length, and then give them the room first, and then second shortest length.
Amazing, amazing. Right? So Pranav is saying, look, this is good, but Pranav says I have an interesting algorithm that works, and Pranav's algorithm is very intuitive. What Pranav says is that, so this is algorithm by Pranav, and Pranav says that give the room to the interval, apologize for my writing, to the interval with the shortest length Again, remove all overlapping intervals. And repeat. Amazing. Very good. Agile Matthew, all good?
Yes.
Okay, very good. Mahita K, do you see why Pranav's algorithm works magically well?
Yes.
Okay. Travis Matta, do you see why Pranav's algorithm works well?
Yes, sir.
Okay, very good. Now let me ask you this. I am still very proud of my algorithm, which is this due to Rajiv, and this algorithm is due to Pranav. Let's say that I am coming to sell you this software based on this algorithm. Let's say I'm going to charge you $100 for the software. Pranav, being very competitive, he says, okay, I will charge you $99 so that you can take my software. Which software will you buy for this problem? Abhiraj, which software will you use? Rajiv's or Pranav's? Okay, Siddharth Mukherjee, which algorithm will you use? Which software will you buy? Rajiv's or Pranav's?
I think Rajiv's.
Rajiv's, thank you. Yes, Paul, which software will you buy? Rajiv or Pranav's?
Rajiv.
Very good. Pranav, unfortunately, you don't have much support. Aryan, which software will you buy? Rajiv's or Pranav's?
Well, I feel Pranav's.
Pranav's. Okay. Baba Das, which software will you buy? Rajiv or Pranav's?
Sir Pranav's.
Pranav's. Okay. Prashant Trivedi.
I would buy Pranav's.
Oh my God. Okay, Pranav, you really have some good friends here. Okay, so it turns out that both of these are pretty bad softwares. Are pretty bad, right? Why? Because let's take an example of Rajiv's. And let's take an example for Pranav. I'm just showing you why they both actually don't work, right? So in Rajiv's case, let's say that somebody comes early on and takes the entire day, tells me I'm going to take the entire day, and there used to be, and there are others who come late. I could have easily got $4. I could have easily got $4 by picking these 4 intervals. Whereas if I use my algorithm, I will pick this and things will be bad. I will only get $1. So Rajiv's algorithm is suboptimal. It does not give me an optimal answer. Now let's see why Pranav's also doesn't work, right? So Pranav says, choose the shortest interval first. And his intuition is correct. He's like, look, I want somebody to use the room for the smallest amount of time. But then imagine these two things here, right? Pranav would have chosen, Pranav would have chosen this, and let's say God would have chosen these two, right? So once again, Pranav's algorithm doesn't work very well too. Can somebody tell me, give me any other suggestions? Let's see. Srish Nayak.
My idea is try to mix both of them. Take the good parts of both of them.
Very good. Take the good parts of both of them. That makes sense. Abir Pandit.
So yes, I had a similar idea, sir. I was thinking that maybe we could take the most and have the least amount of time in between, like you said.
Okay, so, very good. All good ideas. Let me just give you a very simple and intuitive algorithm. In interest of time, I would have taken this discussion a bit longer, but I don't have that much time. So let me give you an algorithm. Choose the interval. that finishes first. Give the room to the above interval. Remove all overlapping intervals and repeat. Yeah, just repeat the 3 steps again. What is the intuition as to why this should work? Again, I can do an entire proof. I don't have that much time. But the intuition is that once I get my $1, what do I wish? I wish that that person leaves the room quickly, because so that I can get my next dollar, right? And that's the intuition why it doesn't matter when they come. I just want to get my $1 and have them leave my room as soon as possible. Yeah, so that's why this algorithm is actually optimal. Any questions, anyone? Okay.
So what was the difference between Pranav's and this algorithm?
Sorry, say that again.
I didn't get the difference between this algorithm and the one of Pranav's.
Ah, very good. So you see, Pranav's algorithm says choose the interval with the shortest length, shortest duration. So what Pranav's algorithm would choose is this, whereas the earliest finish time, that is, let's say the so-called God solution, which we don't know, would pick this, the orange one.
Yes, sir.
Right? And then what God solution will then pick will be this one. So God solution will get $2, Pranav solution will fetch us only $1.
Oh, right.
Yeah?
Yes, sir.
Good. Any other questions? Okay, Prashant Trivedi, I'll take a quick question and then move on to the next one. Okay, all right. So let's go to the next question. So imagine that there is a curfew in Kolkata, right? There is a curfew in Kolkata. We want, let's say that you are the director of Kolkata Police, and you want to make sure that so the scenario is the following. You have a curfew in Kolkata, and you want to guard each street. What does that mean? We want a police officer, we want an officer to be able to see, okay, so how do I want to say, okay, so I want to place an officer, let me say that better, place an officer.
Supervise.
Yes, supervise, good. Place an officer on each street to supervise that street. Good, right? But you know, I am at a dilemma because all this happened very quickly and I don't have that many officers, right? So I want to minimize the number of officers so that each street is guarded. Right? I want to minimize the number of officers. So, for example, let's say that these lines are the streets of Kolkata, right? Let's say these are the streets of Kolkata. Now, one solution is I can place an officer here, I can place an officer here, and I can place an officer here.
At the intersections.
Right, the officers will all very good, right? So one observation is that it does not make a sense to put an officer in the middle of a street, because if they are at the intersections or junctions, then they can observe both streets. So in this case, let's say we use 3 officers to guard all the streets, right? To guard all the streets. Note that every street has at least one officer being able to guard the street, right? I want to find the minimum number of officers to guard all the streets of Kolkata. Vian Pipil, do you have a question about this problem?
Yes, sir. I did not understand what are you like saying in this problem.
Sorry, can you repeat the question? You are not understanding what?
This part, the one you just teaching right now.
Okay, so I'm just saying that imagine that there are streets in Kolkata. So each of these lines is a street in Kolkata, right? And you want to assign police officers to the intersections, let's say, so that every street has at least one officer who guards the street. Like this street here has 2 officers guarding the street. That's fine. But I want to make sure there is at least one officer guarding every street. Is the question, and I want to minimize the officers. Obviously, I can put officers at every junction and guard all the street. That's easy, but I want to have the minimum number of officers to guard all the streets. Before I ask people for suggestions on how to solve this, I want to check. I want to make sure that everybody understands the question. Any questions about the question?
Yes, I have a question.
Go ahead, Srini.
No, sir, this is Aryan. So, like for the upper curved street, would one police officer be able to see it?
Yes, very sorry. So the curve is just a notation. I mean that there is a road between that. So if that bothers you, we can make it. Okay. So yes. So don't worry about the curves. Okay, good point. Let me just redraw this. Okay, sorry. Okay, Srini, are you good now?
I wasn't talking then.
Yes, I understood. This is
okay. Okay, good. Any other questions about the problem?
Oh, I have a question.
Go ahead.
You see that on the bottom line? Can one officer cover that whole bottom line or no? Because it's like a straight line basically.
Well, so this officer here can guard this street and this street. This officer here, let me use a different color, can guard this street, and this street. Okay. This officer here can guard this street and this street and this street. And so every street is guarded, so life is good, we are done. Okay? Basically, if you have a line that touches, let's say this we call a vertex or a point, whatever you want to call for now, then an officer there can guard all the streets that hit that vertex or a junction, if you will. And I want to find again the smallest number of officers to be able to guard all the streets. Anushka Agrawal, do you have a question or do you want to give suggest a solution?
I have a solution.
Very good. Please go ahead.
Select the vertex with where the most intersections are.
Very good.
Remove all of the endpoints. Like remove all of the junctions. What?
Amazing. Right? What Anushka is giving us is a very intuitive solution to this. That Anushka said, look, I will pick the junction which has the highest number of lines that come into it, because if I put one officer here, then I can take care. If I put one officer here, I can take care of all these streets, right? I can take care of all these streets, right? And that makes complete sense. Do we understand what Anushka's algorithm is? So algorithm, due to Anushka, it says that pick a node, I'll just say node or junction that has maximum number of streets, let's say for lack of better phrase, coming into it. Very good, right? We can note that, place an officer there. Place an officer at the node. Right now, remove those streets from further consideration. And then repeat the above steps until no more streets are left to be covered.
Sir?
Very, very good. Yeah.
Sir, I have
Good.
a doubt.
Okay, go ahead. Just right. Yeah.
Yeah, I didn't understand the third point. Remove those streets from
Yeah.
further
So
consideration.
okay, very good. What Anushka is saying is that look, once. Okay. So let me take an example. Let's say these are the streets, right? And what Anushka is saying is, because this is the vertex that has largest number of streets coming in here, she says, I will place an officer here. Once she places the officer there, she says, I will remove the street, I will remove the street, I will remove the street, I will remove the street. Sorry, she cannot remove the junction, so they will still be here, right? And something like this. So this is how, and I think there was something here, right? Whatever, right? So this is how the new map will look like. Jasraj, does that help?
Yeah,
and then she picks the next junction with the largest number of streets coming into it, which is this, which is which is this. Yeah, and then she will place one officer here, and then she will remove this, this, and this, and now all this. I mean, there are no more streets to be covered. And she said, "Look, I could find the solution with only 2 officers. So in this case, only 2 officers. That's an amazing algorithm. Good, very good. Vivan Rastagi, go ahead.
Sir, I had the same suggestion.
Okay, good. Do we all see why this algorithm works well? Do we all see the intuition as to why Anushka gave us that algorithm? Uttam Tripathi, all good?
Yes, sir, I want to answer this.
Okay. Raj Jain, all good?
Yes, so I only wanted to add like one point that we should first start from the center. We should first start placing the gods from the center and then move towards the edges.
Okay, that's an interesting suggestion. Okay, very good. Otherwise, everything is good. Vian Pitil, all good?
Yes, sir.
Okay, so in interest of time, I just have a few minutes left. So I will just say, unfortunately, this algorithm also does not work. In fact, I can give you an example where it will do much worse than God's solution. So God, let's say, knows the optimal solution. This will do quite worse than God's solution. Yeah. But Anushka should not be discouraged because for this problem, no one in the world knows an efficient solution. And And if one gets an efficient solution that solves this problem optimally, there's $1 million on this problem. Yeah. But what I will say, there is a very simple, very easy to approximate solution. What does this mean? I'll just say what this means and we'll stop. After that, the technical content of this presentation. This just says that if God assigns 500 officers, right? God knows how to do the optimal answer. My solution, our solution, will be at most 1,000 officers. Right? That's all. That is not hard at all. I don't have time to go into it, but no one in the world knows how to solve this problem optimally. It's a very important problem in computer science, data science, and so on. But and there are people thinking about it and so on. So I will stop the technical part of the presentation, and I will move on to say a little bit about PACT. Atani, is that good? Can I switch over to talking about PACT now?
Yeah, absolutely, sir. Please,
okay.
Please.
Okay. All right. Good. So just give me a second.
Just
Sorry, go ahead.
Preface. Basically, Professor Gandhi will talk about a very interesting program that he runs. It's called PACT. So he will share about it now. And after that, if you have any questions, you can always raise your hand, and in the next phase, Professor Gandhi, the next phase, the moderator will be Shaif Mushid. He has joined already. I will be exiting the call because I have another one. So Shaif will be helping you through the rest of the process. Okay.
All right. Great. Thank you, Shaif. Yeah. No problem. Yeah. So let me quickly go over this. So PACT is a program. PACT, the full form is Program in Algorithmic and Combinatorial Thinking. This is a program I've been running since 2009. It started as a very small program, but it has now grown into a pretty large program. And each year we have a big contingent from India who participates, a big contingent from Kolkata, actually, who joined the program. So let me say a little bit about the program and its impact. So a little bit background about myself. I got my PhD at the University of Maryland. I've been teaching at Rutgers Camden since 2003, and we started PACT in 2009. I also work a lot in India. I was a Fulbright Fellow to teach in India in 2011. I've also been teaching at UPenn since 2013. So it's been about 12 years that I have been teaching at UPenn and at Rutgers concurrently. And with high school students, so the program started in 2009, 2010. I met with the students every other Saturday for a couple of hours. And then once I just made a remark that if any of the students wanted to work with me over the summer, we could do that. I was not very serious about it when I made the remark, but I got this email from Sean Lowen. You mentioned today if you were interested, we could possibly do some work with you over the summer. I just talked to Andrew Wynn about it, and we are both interested. So that's how the summer program started. I just want to mention an aside that Sean Lowen was a high school student when he wrote this to me, and he had admission into Carnegie Mellon. But when I got the Fulbright Fellowship, he actually turned down Carnegie Mellon to come with me to India, and he studied here for a semester. And and after that he went back to college here. So just in short, PACT started with 12 students in summer of 2010, and then the program moved to Princeton. We ran the program at Princeton for many years, and then during COVID, the program went online. And now, because I teach at Penn and because of ease of logistics, we are running the program now at Penn. And so just to let you know, during summer 2025, we had about 175 students, 150 students studied the math foundations, basically the science behind computing. See, most people think computer science equals computer programming, and that's very, very far from the truth. So what we focus on is the science behind computing. There were 100 students online, people who could not come to participate in person, but all the sessions were synchronous. So there were people in front of me physically in the classroom, and then there were people online from different countries, including India, China, Korea, Europe, Australia, and such. And then we had 30 students who were doing advanced algorithms, which is essentially topics that are generally taught at PhD level at most schools. And we have had tremendous impact. Just to give a very small sample, Jagdeep Bhatia from PACT-16, PACT-17, who finished his undergrad from MIT, was the second place in the region on Science Talent Search, winning $175,000. And now he's a PhD student at UC Berkeley. So, students who have got to PACT, they start the research very early in their undergrad studies. Needless to say, students get into top undergraduate programs. I mean, we don't focus on that. That's not our focus. But, as a side effect of good learning, if they get into the schools that they want, that's all great. And many students then go on to pursue their graduate studies and are in top graduate programs. So, the students have gone on to all the well-known schools in the country, and there is a large PACT contingent at each of the schools. And these are the emails that I get from students. So this is a very recent email. I hope this email finds you well. I'm thrilled to share some exciting news with you. I've been admitted to Brown University. I couldn't have achieved this without your recommendation. Thank you for your support throughout the process. This is a student from a small town in India whom I started working with, and this is 2 years ago. This is like 2 years ago when he got into Cornell. Just wanted to share some updates. I got into Cornell University's College of Engineering. This decision was released yesterday, but I was waiting on the financial aid information before sharing the news. Then just now I found out that I have received the Tata Scholarship covering all of the tuition, housing, dining, and some miscellaneous costs, blah, blah, right? So, there's a lot of amazing things have happened. This is a student who got into Princeton last year. I've gotten back my decision that I've been accepted to Princeton. I'm committing, and I wanted to let you know and thank you for all the help and support ever since we first met 2 years ago. And so, just in interest of time, I'm moving a little quickly. And this is again a student who went to Berkeley. It is in my high school sophomore year. I participated in PACT 2020, where Rajiv truly inspired me to pursue a CS major at Berkeley. The key thing is what he writes now. He says, PACT enabled me to ace the most challenging CS theory class here due to substantial amount of content overlap in combinatorial and algorithmic content, and so on. And, just the last few sentences, thankful for PACT. I finished my CS electives at a much faster pace than peers and succeeded in tackling research problems. The key thing is, once you go in with a strong foundation, you can essentially start research early. And to me, that is the key. That helps you get better internships, better, graduate school when you apply to them, and so on. This is again an email from a student telling me about their experience. I just wanted to thank you for making PACT not only an enjoyable and challenging experience for me, but also a transformative one. In just 1 month, I grew both as a mathematician and as a student. My only regret is not attending the program a year or two earlier when I had more time. Some of you may have known about USA Computing Olympiad. Our students do well there. Again, I do not focus on training people for competitions. I want to focus on people learning the right way and let the competitions and all such happen as a side effect of good learning. But I recently participated in the recent USECO contest, and I received a perfect score in the silver division, which I entirely attribute to the knowledge I gained at PACT. As a frame of reference, in the contest before PACT, I scored only 27 out of 1,000. This is an email from a parent. I decided to wait until you finished grading the final exams and writing letters of recommendation to write. I just wanted to express our thanks for all that you have done for Matt over the past 2 years. About a week after he received offer from Caltech, his admitted students packet arrived. I guess it's a tradition for their executive director of admissions to write a personalized note. Matt said, your theoretical approach to CS is a great fit for Caltech. I remember you mentioned over the summer that you don't know if PACT helps applicants get into college or not. PACT clearly helped Matt get into Caltech. I will still say that, I don't teach with the intention that people get into colleges. That's not my goal. My goal is to teach things what I think will help students regardless of what college they go. As a side effect, if good things happen, they get into the dream schools and so on, that's only a plus. But all I will say is at this point, most of the colleges know about PACT just because they have been running the program now for over 15 years. And students from PACT have been able to audit courses at Ivy League schools. So for example, our students have audited courses at Cornell, Princeton, Penn. Like Sunny Lu from China took courses at Penn when he was in 7th grade. Sambar Shah from India did the same, right? So they did Penn courses. I helped facilitate that. Sitting from India, they were able to do it. And currently there are other students doing the same. Mentoring continues long after PACT. People come to me all the time and the next email shows this. This is an email from one of my colleagues at a top university. Today was Mike's last day working with me, and I wanted to thank him most sincerely for recommending him to me. So Mike was a PACT alum. He was a first-year student at Carnegie Mellon. I recommended Mike to join this research group, and I called up that person there to take Mike, and he's amazing. He's incredibly smart, well-prepared, and tenacious about working on hard problems without giving up, and so on. The point I'm trying to make is that what our goal at PACT is to prepare students in such a way that when they start college, they can start research soon. Otherwise, people take courses at freshman year, sophomore year, junior year. By the time they get senior, that's when they can make barely contributions. With PACT, you can start all those things much sooner. Again, as I said, my support to students stays long after PACT. So this is a student, Sheel, from, again, India, who got into a top school, and he was not admitted in computer science. I called up the people there and said, look, this guy is potentially a future star. Take him. Then he was a freshman. Because of my work, they allowed him to take a 4th year, that is a senior level computer science class. And this is a note I get at the end of the semester. There's a quick note of thanks sent with Sheel's permission for introducing us and encouraging me to find a way to let him take my majors only programming languages course this fall. Being a large institution with unmeetable demand for our courses, we rarely allow such exceptions, but I took the chance for Sheel, and as it turns out, one other first-term freshman as well. Sheel ended up with the highest grade in the course, basically tied with 2 other students in a class of 75 students. He received 100% on the final, blah, blah, blah. The last 3 sentences, Sheel is surely special, but it's also great evidence that those of us trying to manage large organizations and enterprises do need to be mindful of making exceptions. Once again, as I said, we prepare students to do amazing things in higher education. And I'm part of the higher education because I teach at Penn, I teach at Rutgers, and so on. So I'm very well aware of what it takes for students to do well. And, long story short, Sheel not only did well during his undergrad, he's now a PhD student at UC Berkeley. Just a little bit about some logistics about PACT. It's a 4.5-week program, and there are lectures every weekday, and including guest lectures. My lectures will be on combinatorics, probability, proofs, graph theory, and we give an introduction to algorithms. There are recitations each weekday. I have just written the times in IST just so that it becomes easier for you. We cover topics from a course CI 1600 at Penn, and we don't like to leave students once we start working with them, because the goal is to instill the right work ethic, the right habits, the right way to think, and so on. All the problems that I presented today right, during the lectures is basically the foundations of computer science. These are all the things that we cover in PACT. We also have a PACT year-round program, which starts once PACT summer program begins and continues during the academic year. I will stop here just because I don't want to take up too much time, but I'll be happy to answer any questions that people may have. Srini, go ahead.
How can I apply to this program?
So I should have mentioned the applications will open probably mid-November. Until this year, they always used to open in January, but a lot of people have shown interest and they want to join the program, so we will open applications in mid-November. Yeah.
All right, thank you.
Sure. Any other questions? Yeah, go ahead, Jasraj.
Sir, like how will we get these applications?
I'm sorry, say that again, please.
Where will we receive these applications?
I'm sorry, where will the applications be? Is that the question?
Received, yeah. Like where will we get it?
Oh, so if you go, okay, I should have mentioned, let me see if I can do one thing. Just give me a second. Okay, so I can write here. So if you algorithmicthinking.org. Yeah. So I think if you go here, again, we have not yet started accepting applications. The information which is there is outdated because that was for the previous year, but we will update it in the next 1 month. Yeah. Vivan, right. Yeah, no worries. Vivan.
Sir, will these algorithms help us only for like college applications and all, or like will can we use them for like businesses and like make business ideas easier and invest on something?
So, as I said before, we do not teach for college applications. That's not our goal. As a side effect, if something happens, that's fine. This is a program that will teach you how to think no matter which field you go to. Many PACT students, the very first PACT student actually, David Jacobowitz did his PhD in biophysics at Harvard. So one doesn't even have to do computer science. One can go to any field. This will always be useful. And that's the point I made when I started the lecture with GCD, that there were no computers, but Euclid still wanted to find GCD efficiently because that was the problem of interest then. So it is a way of thinking that will help you no matter what you do, Vivan. Does that answer your question, Vivan?
Pretty much.
Okay, good. Yes, go ahead. Prashant, go ahead.
Does this course also works in American time zone? Would this also apply to American time zone?
So two things I should say. One is there is a PACT Asia version. You should ignore that because that is primarily generally run in China. So you should look at the regular PACT, and the times that I mentioned are the same times when we meet in America. It's just the corresponding time. So let me go here and write. So this time here is the same time when we meet in the US. So that is 11:30 a.m. to 1:30 p.m. Eastern time.
So
that is 9 to 11 in India. And it has been designed that way because this is the time that works for most students in India. Go ahead. Yes, Prashant.
So is this every weekday? Because at that time there'd also be school, at least for us.
Keep in mind, this is PM. There is no school in PM, I assume, from 9 to 11. We've been running this program for 15 years and it works quite well for most Indian students. So There is no school, and this program runs, as I said on the first page. The dates are here.
But I'm in USA, so for me it'd be in AM and PM, right? So I wouldn't be able to take it.
Yes, there is no school in a school generally finishes in the third week of June.
Oh, so it'd be in summer. All right.
Yes. Any other questions? Anushka Agrawal, go ahead.
My question was if this course is only helpful if you're majoring in computer science, or could it be useful in other applications?
It has not. So, if you major in computer science, there's obvious help, but no matter what field you choose, this will be super useful because it teaches you a way to think, number one. Number two, if you go to any STEM field, let's say you go into biology. I have a student right now working in a bio lab, and she did PACT, I think in 2018, and she said that, this is very useful because what they do is design algorithms for genomics in which they do research, and then they write programs after they design the algorithm. So yes, no matter what field in STEM that you choose, you will find it useful. Is this useful for English? Probably not. I mean, directly useful, but it's still a way to think.
Thank you.
No problem.
Excuse me, sir. Yes, sir. So would there be any sort of screening process for the program?
Yes. So once you send the application, the committee will review it, and then we will send acceptances.
Okay. Thank you, sir.
Yeah. Okay. Any other questions? Srini, do you have a question?
Oh yeah, like how many people apply to this program?
All that there is, we don't reveal all that information. But let me just say, a lot.
Okay.
Yeah. Vivan, do you have a question?
Yes. So I opened your site. So for the letter of recommendation, is it necessary?
Letters of recommendation are necessary. We have said we need 2 letters of recommendation. Generally, one works. And sorry,
and
go
the
ahead.
fee structure, are they monthly or like quarterly?
What is monthly? Sorry, what is the question?
The fee structure, the fees.
It is not monthly because the course runs for 4.5 weeks. It's an intense course for 4.5 weeks. But we do work with students in different ways to help them, financially and such. So feel free to email at the email address that is given there in PACT, and someone, either me or one of my colleagues, will be happy to respond.
Okay, sir. Thank you.
Yeah. Okay. Good. So if there are no more questions, we can end. Shaif.
Shaif is also here. Yeah, Shaif, go ahead.
Hello.
No, it's fine. Like, you can go ahead. I didn't know you guys.
Okay, yeah. Thank you, Professor Gandhi. It's awesome to hear from you, especially about the algorithmic thinking. This is really one of the central things in problem solving. So thank you for that. I'm sure many students will be very interested in the programs that you offer. And thank you for joining in today. Thank you to all the students as well.
Folks, thank you again, Shani, for inviting me. And folks, it was absolutely a pleasure interacting with you all. Thank you. Bye-bye.